This lesson we are focusing on transformation of quadratic graphs. So what are the three different types of transformation? It is dilation, reflection and translation. So dilation means it stretches the graph parallel to the y-axis or parallel to the x-axis. Then translation, there is two different types of translation, the horizontal translation and vertical shift. And then we have the reflection. So when there is a sign in front, when there is a negative sign in front of the function, that means it is reflection parallel to the x-axis. So let's look at this equation. Y is equal to 8 times of x minus b the whole square plus c. A represents the y dilation, the dilation factor parallel to the y-axis. So then we have x minus b the whole square inside the bracket. This x minus b represents the horizontal shift. So when there is a minus, when it is x minus b, when we equal that to 0, it becomes x is equal to b, which represent a horizontal shift b units to the right. If it is plus, if it was x plus b, then it is b units to the left. And this plus c represent the vertical translation. So if it is plus c, it is shifted vertically up. If it is minus, it is shifted vertically down. And when there is a sign in front of the function, then it is reflection parallel to the x-axis. So let's look at the three different types of transformation using Desmos. So let's look at this graph here. Y is equal to x squared. So you can see the graph, it passes through the origin. So the vertex is 0 and 0. Let's check the dilation factor. Okay, so I'm going to insert an equation which is y is equal to 2x squared. So you can see the graph, the purple graph represents the equation y is equal to 2x squared. So when the dilation factor increases, the graph becomes more narrower. Let me enter another equation. Y is equal to 0.5x squared or half x squared. So now you can see the green graph, or it is actually the black, not the green, the black graph. You can see when the dilation factor is lesser, the graph becomes more wider. As the dilation factor increases, that means the graph becomes more narrower and more steeper. Okay, so that is all about the dilation factor. Next, we will actually look at the translation. Let me enter an equation which is where there is a horizontal as well as a vertical translation. So x minus 3 the whole square minus it. I'm just entering an equation here. Let's look at the graph here. So you can actually see y is equal to x squared is shifted 3 units to the right and it is vertically shifted 8 units down. So x minus 3 means equal that to 0. So x is equal to 3, which means the graph y is equal to x squared is shifted 3 units to the right and minus 8 represent it is vertically shifted 8 units down. Okay, so that is all about the translation, the vertical shift as well as the horizontal shift. So if you want, you can actually, let me show you another equation. So y is equal to x squared plus 5. So x squared plus 5 represent the graph. It is shifted 5 units up. The same graph y is equal to x squared is shifted 5 units up. Let me enter another equation where there is a horizontal shift. So y is equal to x plus 2 the whole square. So when you look at the graph here, y is equal to x plus 2 the whole square. So the graph y is equal to x squared is shifted 2 units to the left. So you can see the purple graph in here. So it is shifted 2 units to the left. So one graph is shifted 5 units up and you can see the second graph it is shifted 2 units to the left. So let's check for the third type of transformation, which is the reflection. So therefore, let me enter. So y is equal to, if I enter it as minus x square, y is equal to minus x square. So how does the graph looks like? So you can see that when there is a minus in front of the function minus x square, the graph is reflected parallel to the x-axis. So thanks for watching. That is all about the transformation of quadratic graph.